In today's program, this title was Something Old, Something New, and Something Experimental. Richard's going to start talking about features that he designed and implemented in version 15, been available for a year. Cross-platform native file functions. He's also going to give you a sneak preview of a CSV system function that is in fact available now if you join the beta program for version 16. Version 16 is now about 6 or 7 weeks away from release, and the betas are available. And I'll wrap up with a talk on an HTML renderer component, which is still a little bit experimental. We expect this to last somewhere between 60 and 90 minutes, depending on how much interaction there is. And we hope you enjoy the show. And with that, I will hand over to Richard.
Okay, thank you. That was a fairly low-tech handover, I'm afraid. We changed microphones and so on. Yes, I was going to talk about old things. In fact, I'm going to go way old to start with and go straight into a demo with our native file function support that we had way back when. So let me bring up the demo. I don't know who we've got online at the moment, but this is the Dialog APL session, and everything that I type is fortunately in a text file, and I'm just going to bring it up with this square bracket demo command. And the first thing I'm going to do is switch on boxing, which is just going to show the results of arrays with convenient little boxes around things so that we can see their structure a little. And I'm going to be messing around with some files. So what I'm going to do is bring up Windows Explorer so we can see what happens in the file system. At the moment, this directory has got 3 files in it. I'm going to put stuff in there, take stuff away, and we should be able to see all that happening. So this is pre-15.0. This is before last year. The kind of commands we had to deal with files within Dialog APL. So we have native file functions. NCREATE creates a file. It's very good at dealing with binary data, and I'll show you an example of that now. So I create a file. I'm writing some binary data to it. I'm going to write 20 random numbers. They're going to be 16-bit binary integers. And this reads them back. So I can read and write binary data to files very easily, and it all works very well. And similarly, we can do text, so let's get rid of that file. Oh, by the way, you notice that the file I created appeared in that directory. That's useful for later. Okay, so let's do something with text. Create a text file. It appears in the Explorer window. I put some textual data onto it. I can read it back. There's some text. And it's a text file, so I'll start Notepad up on it, and we can see that it's created a file that the operating system is perfectly happy with. All is good. So let's try and make this a little bit more interesting, this text file. We'll put some line endings into it. So first thing, we'll define the the ASCII byte sequence for our carriage return line feed, which is 1310. And we will put on the file a couple of lines now. You can see that I put a carriage return line feed twice in that text to end 2 separate lines. Let's untie that, look at it again. Again, Windows is very happy with that. It's a very simple text file with 2 lines in it. Let's try another one. This time, I will put some different text in it. Notice that this one's got a Euro character in it, and I can't write that to the file. The reason being that the Unicode code point of the Euro symbol is way out of the range of single byte characters, which is all I was writing to the file. But that's okay. I know that the Euro symbol is in an extended ASCII character set at code point 128, so I will write it to the file in that form. We'll have to write unsigned int, so I've got a little function there to turn unsigned into signed, so I have to write unsigned. See, what I actually want to write is minus 128, but there's my Euro character. It doesn't look like anything in APL, but if I write that to the file, and bring up the text file again, Windows has correctly recognized that there's a euro character in there. Good. So, okay, it's working. It's getting a little bit cumbersome, but it's all working. Let's try our next file. This time I'm going to write a quad character, an APL character, this one here. Now that's not even in the Windows 1252 extended character set. So now I'm going to start writing UTF-8. So I've got this quad UCS function with a left argument of UTF-8, which will generate the byte stream for that. That's what it looks. No, it's not what it looks like. Excuse me. Something has gone horribly wrong. Help. Right. Something went very wrong. It always does when you're doing stuff live. I think that's where I got up to. Yeah. That's okay. I'm rerunning the things that I've done before, so the file is already there. That's okay. There we are. There's the byte sequence I want to write to the file. There I am writing it to the file, and when I bring this file up, there it is with the quad symbol in it. You'll notice that Windows has successfully decoded those files, worked out that one was Windows 1252 extended ASCII, the other was a completely different encoding UTF-8. Right, so let's bring up, I've lost my other thing here, let's go back to that. Let's bring up this, this is the files that I was showing you before. I don't know why that disappeared. I'll work it out when I play everything back again. I can erase the f1.dat file. That was the one that I first created. So you'll see it's there in the list. There we go. It's gone. The way that I did that was I tied it to read it, and then once it was tied, I ran the quad NERASE command. That meant that I had to have permissions to actually open the file, but otherwise it did allow me to delete the file. Let me just put it back again on the file system, just so that I can show you, because there are issues with having to be able to read it. What you tend to find was that people would start running Windows commands to actually do these file deletions. So instead of using the native file functions that were built into APL, people would just shell out and run the Windows command del, which got rid of the file. The problem, of course, with that is that it's very, very platform specific. Similarly, I would shell out to do things which there was no native support for. You can't create directories in earlier versions of APL using any built-in APL command functions. So I can do that. Now you'll see that directory D has arrived on the machine, and similarly, if I try and create that one, you'll see one of the problems with using the shell commands is that that has errored, but it hasn't given me any feedback to that effect. Let's instead get rid of the directory D, which I've done. If we want to see what's in that directory, well, again, we can shell out the Windows dir command will give me the list of files that are in that directory, and then I can process them as I want to. So we've got plenty of functionality in those earlier versions of APL, but possibly not in the most convenient form. And when I was creating text files, it got to be a little bit awkward, and so on and so forth. So in 15.0, we added some new functionality, and this is the old stuff that I will show to you first in this presentation. Okay, I'm just going to put the f1.dat file back on the operating system, nothing new yet, and you can see that now I can delete it with this new function NDELETE, and it's gone. If I try and delete a file that's not there, I will get an error. If I don't know that the file's there, I just want to make sure that there isn't before I do anything, I can give an option to NDELETE, and that means delete it if it's there, otherwise don't. It doesn't suppress all errors. as you'll see in a moment, if I've got a function here to make a directory. Similarly, I will get an error if it already exists, and similarly I've got an option to say don't worry if it's already there. I can delete a directory. This is the point I was trying to make just now. If I try and make a directory and say I don't mind if it's not there, if it is there, I will still get an error if the reason for an error occurring is the fact that the file is already there. You can see that it couldn't create it for a different reason in this case. Okay, and I can try making subdirectories. So I've got no directory D at the moment. I'm going to try and create D, and within that E, and within that F. And as things stand, that will fail because D and E aren't there to put F in, but I've got an option to say create all the intermediate directories as well. And now you'll see that D has arrived on my file system. Within that there's an E, and within that there's an F. Another simple new function is NEXISTS. That just tells me whether that name exists on the file system. As you can see, it does. It's up here. So that will just give me a simple 1 value back. Similarly, that directory exists, but that file or name does not. So it gives me a 0. Now that's a simple and fast check. If we want to know more information about these things on the file system, there's another function called NINFO. The left argument is what we're interested in. The right argument is the file or directory I want to know about. So if I run that, you can see I've got 6 items back. Now, because those are codes, and I can never remember what they mean, let's bring up the help. So I asked for 1, 2, 3, 4, 5, 6. 1 is the type. You can see that here I've got a 2, and 2 means that it's a regular file. Second thing is the size. It's 36 bytes long. The third is the modification time. It's when I just created it just now. The fourth is the ID of the user who created it. That was me. That's my unique SID. And this one is a more user-friendly version of my name. And then the last one was whether or not the file was hidden. And it's not. It's visible on the file system. We can do something very similar for directories. This is almost the same. It was created at roughly the same time. It was created by me. It's not hidden. But now you can see that the type is 1, which is the code for a directory, and it's reported as having 0 size. If we try and ask about something that doesn't exist, we get an error. So let's come back to the file system. We can delete directories. I saw that just now, but we can't delete non-empty directories. You remember it's got things inside it. So what we have to do is delete F, then delete E, then delete D. And now it's gone. And next one we've got is NPARTS. NPARTS takes a file name or directory name and breaks it down into 3 constituent parts: the directory, the base name, and the extension. Here you are. You can see those 3 parts. It hasn't checked whether that file even exists on the file system. It may be that you're trying to prepare a name in order to create it. But it's very useful for taking an existing name, for example, and changing the extension. Here's a little function which will do that. If I take that same directory name, file name I gave before, and said change the extension to .dat, there we go. It's simply done it. That works whether or not the original had an extension, and it works whether or not the original had multiple dots in the file name. So there we go. This one hasn't got any directory. That's fine. It's just empty. There is a option to NPARTS to say rationalize the file name. So if it's not got a fully qualified path, it will create it. This will be what the name would be if you created it. In other words, it prepends the current working directory. So it also rationalizes the name a bit. So if I did /file.txt, you'll see that the last part here will be taken out by the ... like so. This is a little idiom which is useful for getting the current working directory. So I've given it a completely empty name, to which it will prepend the current working directory, and I've asked for just the first element back. So that's a nice little idiom which gives you the current working directory, a kind of quad PWD, if it were, as you were. Now, NINFO, which we saw just now, is very interesting as well in that it has an option to accept wildcards. So before I asked for various properties about a specific file in this directory here, now I'm asking for two properties, 1 and 2, which is the type and size, but I'm asking it for all files which match the pattern star, in other words, all of them. So there are, how many? 6 files in there. So now I get 6 types. They're all 2s, they're all regular files, and I get 6 2s. That's the various sizes of the files. This is particularly useful if you don't give NINFO a left argument, it just returns a name. So this here gives me the names of everything which are in that directory. And this gives me the ability to process the contents of directories in any way I wish. Here I'm going to pass those names into quad and exist. Now clearly they will obviously exist, so this is going to give me a load of 1s. I'll show you in a minute an example where that's possibly more useful. So let's also go to text files. I showed you text files earlier on, and those 3 files I created, f1.txt, 2 and 3.txt, were the ones with pure ASCII, with Windows 1252 extended ASCII and UTF-8 data. The existing, pre-existing native file functions to read those do a reasonable job. There is the pure ASCII one. All the text looks correct. The line endings are embedded within the data, and they're showing up here with the spacing that you can see. When I read the extended ASCII one with the euro symbol in it, the euro symbol's not really showing because it's not the Unicode character that we're expecting here. And the UTF-8 sequence is giving me a sequence of effectively junk because I haven't in any ways decoded this. I would have to read this in as numeric bytes and decode the UTF-8. But however, now we've got functions which will just read text files. Here I'm going to look at f1.txt again. You can see that it has read the file, it has split it nicely into its 2 lines, everything is correct in the data. It's also reporting the encoding that it found in the file, which is UTF-8, and the line ending type that it found in the file. When we wrote carriage return line feeds, that is there. Similarly, for the extended ASCII one, now the euro symbol is appearing correctly, and the system has automatically deduced that this was a Windows 1252 encoded file. And finally, let's look at the third one. I'm also saving the result of this for later use. Again, the quad symbol has been loaded properly. It wasn't in this case earlier on. We've got a UTF-8 file this time, again with carriage return line feed endings. So the corresponding function to NGET is NPUT. This will write a file. So I'm going to write that data straight back again. You'll see that F4 is exactly the same data as was in F3. There it is. I'll put that up anyway. Now, if we change the encoding element of that result to extended ASCII Windows 1252 and write the same data again as F5, it appears. Oh no, it can't because it cannot encode the quad in Windows 1252. We wrote F4 just then. We can read it back. We can read it back in several formats. Here I read it as a vector of character vectors, which is a nice format, convenient format. If I wanted line endings in a stream of bytes, I can have them. Here they are. However, for convenience, although they were carriage return line feeds in the original, they've all been changed to simple line feeds in the actual data, which makes it far easier for me to process, knowing that they're all the same. So let's change the encoding again. We tried to write it as Windows 1252 before and it didn't work. So we'll change it to UTF-16 big endian format. and write that file. And let's see what Windows makes of that. Well, Windows makes a bit of a mess of that because it doesn't really know that encoding. That quad in particular has turned into something very odd. But we can read it. We do understand that encoding. We told it just to read the file. We didn't tell it what the encoding was. If we did tell it what the encoding was, and we lied, in this case I'm telling it it's a little endian encoding, it'll try and do it, but in this case that'll give us junk. And finally, come back to the quad NINFO. I showed you before you can get all the names of files using patterns. So here's a very convenient way of deleting all these text files that I've just created. I'm going to ask it for the names of all the files that match f?.txt, and I'm going to pass those in turn to quad NDELETE and get rid of them. And they're gone. Okay, so that's the end of that part of the presentation. I'm going to move on to something new in a moment, but we'll pause for a moment just to see if there's any questions which people have for me on what you've just seen. And because of the time delay, I'll sit here awkwardly for probably a couple of minutes so that you can catch up. I will wait just in case they come now. We debated this earlier. It's perfectly fine if there's no questions. We're not waiting for questions, but we have to wait because of the time delay, because you might have sent something and I've not received it yet. Okay. Right. Please feel free to continue asking questions if you have any. Oh, I have one. Now the moderator is sending it to me. Did the quad info have a domino after it? No, the quad info didn't have a domino. I think you're talking about this. If I can actually get it. That's very similar to a domino, but it's actually the variant symbol. To fully explain variant will take the rest of the afternoon, but the short answer is it is a mechanism for passing options. And the option in this case was simply 1, which is a code which means process wildcards. If I hadn't put that there, it would have looked for literally the character, the name f?, which would have been an invalid file name, and it would have given an error. In fact, I can show you that. If I could type, I would show you that. So now it's saying that it's an invalid file name because the question mark isn't valid in the Windows file name. Yeah, that's and that just putting a 1 there is a short form for wildcard 1. We can name those options, but for brevity, I have just used the option value. Does this work correctly in OS 10, I'm being asked? Yes, it does, is the short answer to that. We run the QAs on OS 10, and if it didn't work, I would have been got out of bed last night. Why not 20 years ago? Well, very, very good question. I wasn't here 20 years ago. I could accept the answer, why not 9 years ago? And yeah, then you're right. It should have been done a long time ago. It has, I suppose, become more important now that Windows isn't quite so dominant, OS 10 being in particular a major reason for us doing this, I think. Do we have any more? I'm told that's the end of the questions for now, so I shall move on. So, back to my slides. Done that one. You know, I meant to leave that up when I was asking for questions. But hey, nothing ever works. So, something new. So, quad CSV files. we're saying CSV because there is huge debate about what C stands for, but it's either character or comma according to your personal taste. They are text files containing rectangular data, in other words, APL matrices. They are text, but some of the fields tend to be numeric. They are represented purely as ASCII or character strings of numeric values. And everybody has invented a CSV format. There's so many different standards out there that there is no single format or standard we can point at to support. So let's try and show you an example. So first of all, I'm going to show you a CSV file and we're going to try and process it using APL. But in some interesting characteristics about this particular small CSV file are that it's using commas as the separators between fields. The other thing is that one of these fields is quoted, and it's quoted because it itself contains a comma, and we don't want that to be interpreted as a separator. Notice that there are a couple of numeric fields. They are in the second and third lines of the file, but not in the first, because the first line in this file is a header line which describes the columns below them, and that's pretty much always character. There are some non-ASCII characters in this file, like that single O with a line above it, with a umlaut. I'm not quite sure what that's called. And there are some extraneous spaces in this file. It's interesting the way that different interpreters process those spaces at the beginning and end of fields. So there was the example. Let's go into a demo. So back to APL. And you saw quad NGET just now. There's the contents of that file that I was showing you on the slides. And I'm going to bring up Excel and see what Excel makes of it, because Excel can read CSV files. So it's a bit small. Let's make that bigger. Slide a few of these things along. Okay, so what's interesting about this? Well, it's correctly determined that this field was a single field because it was quoted. It's not very good at decoding UTF-8, so it's made a bit of a mess of that. It has preserved the spaces that were in that field, and very usefully, it has recognized that these two fields here are numeric, and it has put, as you can tell from the alignment, it's treating those as numeric fields. So now let's have a look at what APL can do. So simple new function, quad CSV. We give it the name of the file, or we could give it data in the workspace. I'm using a file for this example. Reads in. It has similarly, it's created a matrix of the 9 individual records. It's slightly different from CSV in its default configuration. It has discarded the spaces at the beginning and end of these fields, and it hasn't, in this form, turned those numeric fields into numeric data. We can see that a little bit better if we switch to a more verbose form of boxing. We can see that those are still alpha numeric character data. But we've got options to this. Because there are so many formats out there, we've had to put in a number of options so that you can configure it to the kind of CSV file that you use. But 4 is a special code. We love special codes. Let's bring up the help for this. Where is it? 4. The field is to be interpreted as numeric data, but invalid numeric data is tolerated. So we're telling it that everything could be numeric, but it may not be. So let's bring that in. And now you can see that those 2 fields which looked numeric have in fact been turned into numeric elements within this matrix. Matrices are possibly not very optimal way of storing this data within the workspace, particularly because CSV files tend to have columns of data of all the same type. So we've got some inverted formats, and the first inverted format is to turn the fields into text matrices or vectors of numerics. So here you can see that I've got 3 character matrices for each, one for each of the columns of data. Now, as I said, it's very common for the first line of a CSV file to be a header. So let's separate that away from the data for a moment. Let's put that separate. And now we have the advantage that this column here, the third column, is all numeric. In this representation, it's brought it in as character data, but now I can tell it to bring it in as numeric. So now I've got character column, and a numeric column stored as a vector of numbers. What am I doing in this one? Now I've got a slightly different inverted matrix format. Some people don't like matrices. You've got a load of spaces here. It's difficult sometimes to deal with that. So here we've got vectors of character vectors or vectors of numerics. This is a slightly less efficient storage mechanism, but it's available if you wish. And you notice that when I loaded into Excel, it preserved the spaces. The person who asked about variant, here's another use of it. In fact, all of these are uses of variant, but you can see that I've set the invert option to 1 and the trim option, which defaults to 1 to 0, so that it doesn't trim those extraneous spaces. So now they have been preserved in the data. So let's switch the boxing style back to the minimum. I'm going to write some data out. Now, instead of writing to a file, I'm going to write it just to an array in the workspace to make it a lot easier to see what's happening. So there's some CSV data which I read in just now. If I write this data out as a nested vector of vectors to the workspace, you can see that it's created these 3 lines with the data, with the comma separators, and because this field has got a comma within it, it's put the quotes in pretty much as it was when it was read in. I can change the separator because quite often a different character is used. Semicolon is very frequent. So here I've got semicolon separators, and notice here now that this field is no longer quoted because it's no longer necessary, because there isn't a semicolon within that field itself. Let's change the decimal marker, which was a period, to a comma, and leave the separator as a semicolon. And now we've got commas within these numeric fields, which is, with the semicolon separator and the comma decimal marker, is quite commonly used in European locations. If we only change the decimal marker to a comma, then we end up with numeric fields with commas, and we've got separators as commas. We have to quote the numeric fields, and that shows really that the quotes around these things are no indication that this is character or numeric data. They simply prevent the separator from being recognized as such. And we've got a slightly different format as well. We've shown delimited fields, but we can actually go with fixed width fields as well with this. So let's generate that same data in fixed width fields, 18, 12, and 5 characters long. So now there are no separators. It's purely the position within the lines that determine what this data is, where these fields are. But we can read those back in as well, just as easily by specifying the same field widths. So that's the end of the demo. Let's go back to the slides. Seem to have gone all the way back to the beginning. So, Quad CSV. Recap of what I showed you. It can read and write CSV and fixed width data. It can do it to files or the workspace, and it can read from files or the workspace. One thing I didn't show you is that if it's reading files, you can read it in chunks. You can specify the number of lines from or the number of logical lines from the file to read, so that if you've got a very large file, you can still process it. Because the CSV format is very ill-defined, we've got a number of options to allow you to try and configure it to read and write the file that's suitable for your format. And we've got some memory efficient storage options. So before we go back to Morten, let's see if we have any questions on CSV, quad CSV. Oh. Can you show CSV to JSON as well? Can you show CSV to JSON as well? I'm not quite sure I fully understand the question. We do support JSON, producing JSON text, but I don't understand whether this question is asking me whether you want me to show you that or you want me to somehow connect CSV and JSON. Can whoever asked the question elucidate? The moderator is saying I think this is he export a table as JSON I wanted. Sorry, Morten's written that, and I understand that less than the previous text. Speak to me. I know this isn't supposed to be talking to me.
There was a request for being able to take a table
Right.
with a regular record layout and export it to JSON.
Oh, I see.
That Brian and I were asking.
Right. Okay. So the JSON format in itself does not support tabular data. Only supports vectors. Yes, I shall look at the camera. Yes. Can you do that? Well, I don't know. I can't think of. Presumably the person who's got the question has got in mind a format for the JSON that would correspond to the CSV. I would like them to speak to me offline about that. Richard@dialog.com. Please drop me an email, and we'll take it offline because I don't really understand what's being asked at the moment. There is Fred Hansen has said, can you read individual columns with quad CSV? Yes, you can. I didn't really show that in the demo. What I did show was that I shot through it without explaining. In one place, I specified that the column types were 1s and 2s and 4s to say what kind of data to expect in there. I can specify a column type of 0, which means ignore it. So if I only wanted to read, say, the second column, I could say something like 0, 1, 0, 0, 0, and only the first column would be imported. And it would only import that data if I was reading from a native file. So you could read a very, very big file without filling up your workspace. Hope that helps. Another question coming, apparently. So Roger says, if an application has not been converted to Unicode, is there a substitute for quad colon? Yes. Quad colon can be spelt in two other ways. The most obvious way of spelling it is quad opt, which is a format which works in both Unicode and Classic interpreters. There is also another format which you can only use in Classic, which is quad U and 4 numbers, which I don't know on the top of my head. It is the format that you'll get if you save a workspace using the variant character and load that workspace into a Classic interpreter which doesn't have support for variant character. It will render in that form. So there is a way of typing it in a Classic interpreter, but if you want to write something which is going to appear the same in all environments, spell it quad opt. Any more?
I think that is it.
We think that is it. Yes. So we have to do another low-tech handover.
Yes, we do.
Okay, so we'll be back in a mo.
Okay, we're back. It's a real shame the camera was switched off there because we came very close to spilling 2 glasses of water. One each as we made the switch over. Would have been entertaining. Fortunately, it didn't happen. Right, so after those nice and solidly designed features that you've just heard about, something a bit more experimental, which might generate a little bit more discussion. The HTML renderer. Before diving into describing exactly what it is, I'd like to take a step back and sort of look at the trends we see in how APL applications are being built right now. What I might call business as usual or monolithic desktop applications is still actually the dominant mode of working out there, although people are really starting to break those monolithic applications up now into the next type of pattern that I have, the second bullet point there, what you might call cloudy microservices. So people are refactoring the monolithic apps, creating small lightweight components that get started, or some people are actually starting completely new applications that are designed that way. Often those are characterized by what I would call a heterogeneous tool chain. So you've got APL doing the core calculations in the microservices, but often the front end of the application is written using some other technology, though not always. Finally, we have what I call micro applications, prototypes, or things that are being created at very short notice in a sales situation or because a new market idea has appeared. And these are very often created by what I call subject matter experts, or domain experts is an older term. And for many of those people, a completely APL-based tool chain or a relatively complete APL-based tool chain, including the user interface, is quite important. So we're not giving higher priority to, or we're trying to deal with all of the modes of operation that we can see our users are working in. So for the people doing business as usual, we're enhancing the Win32 based UI, supporting high DPI and other evolutionary features. You know, Microsoft.NET and all of its APIs are really important, both the desktop version and the new core or nano versions, whatever they're calling them. Performance, quality, and even more performance to support the bread and butter applications. The new thing is these cloudy microservices, or things that are in general working in the cloud. We're doing a lot of work there, building cross-platform tools. So we had a question about whether Quad CSV works on Mac OS. Everything that we're doing these days, we're designing from the beginning to work on all of the platforms, and we're adding platforms. So Mac OS is recent, Android is coming, and so on. There are various other things, support for JSON, XML, HTTP support in the communications layer, so applications don't have to deal with the protocol. Tools to make it easy to share data and have really fast startup of these microservices, memory management, and so on. But the topic, the HTML renderer, is really something that's aimed, I think, primarily at micro apps, though we'll see a few use cases now that it might actually be a useful tool in other situations as well. But the micro apps are sort of really what APL has been doing really well for 50 years. And on Windows, the Quad WC system function for Win32 applications really enabled this kind of development. It was very successful with that. But in the future, we need a user interface that's going to work on the desktop still, because it's going to be around for a long time, but also on tablets and phones, and maybe user interfaces projected by things running in the cloud that don't actually have a visible platform on, but might be generating HTML-based UI in addition to running as services. So enter the HTML renderer and these three technologies that we see at the top right here. So we're betting that HTML, JavaScript, and something called cascading style sheets, which allows you to control the formatting of HTML, JavaScript, are I mean, they are already supported pretty much everywhere, and we're thinking of them now as the Win32, if you like, of the next couple of decades. And this HTML renderer component that we're adding is going to allow Dyalog applications on any platform to use the same code to generate user interfaces. And there's quite a significant challenge in designing this, because we want to make it easy to use these technologies in the same way that QuadWC made it very easy to use Win32, without understanding all the details of making those function calls. So we want you to be able to create these user interfaces without maybe running an actual web server, unless you have good reasons to do that for management of processes and so on. You may or may not want to use a web server. We definitely don't want all APL users to be forced to learn JavaScript. At the same time, we want to make sure that anybody who is comfortable with JavaScript or does want to learn these technologies, cascading style sheets, should be able to take full advantage of the technology, which was one of the weaknesses, if you like, of the older technology, where although .NET and COM came along and made it possible to have custom components, that's quite different from how easy it is to do that with JavaScript. You can really easily break out of the box. So we want to make it easy to use and easy not to use. So I've prepared a number of demos to show different use cases of this technology, show you what you might use it for, and then we'll see if that generates any discussion. So one of the things that I think some people might want to use it for immediately is we have a graphics package called SharpPlot, which is now available, will run on the Mac and on Linux as well as Windows. You can do things like, here's a contour plot. I've run a function here. This is one of the samples. In the SharpPlot workspace, there's a very large number of samples, and the contour plot is one of them. Now, wouldn't it be nice to be able to just get that to pop up on any platform? And that is, in fact, what the HTML renderer allows you to do. So what I actually did there was I created an HTML renderer object. I gave it a size of 800 by 1000 pixels. And then I called the contour sample, which returns an instance of a SharpPlot object. I called the render SVG method with a parameter of fixed aspect. And that returned scalable vector graphics, which is a format that most HTML renderers will accept. So I'm assigning it to the HTML property of the HTML renderer. And although it isn't strictly HTML, the graph appears immediately. And I could run the Gantt chart sample or oops. I had a little keyboard malfunction as well. Well, what you can do is you can go into samples and you can auto-complete. Oh, how about a tower chart? Render SVG mode, fixed aspect, and there's a tower chart. Yeah, so that's a very, very simple use of the technology, something that anybody can use right away on any one of the platforms. Okay, so the next demo is one where you have your old application, an existing application created using QuadWC. So here's your corporate application. It's got important stuff in it. Somebody's very interested in prime numbers. They've copied the prime number function from the defense workspace, and they're using this 0 PCO, which gives you a 1 if something is not prime. And just show off a function or an operator from version 16. If I say star at and a function 0 PCO applied to a number, that will take iota 8, and where this is true, this function returns true, it'll replace values from the left. So I can have stars in there for anything which is not considered prime. So if I now create a grid object in my old style Win32 application and I populate it with the 10 PCO applied to the 1010 reshape of IOTA 100, I get a grid object 10 by 10, which doesn't look very good until I set the title height, title width, cell widths and size. And now I can see that prime numbers get less and less. The density of prime numbers decreases as n increases. Okay, now a colleague said he would really like our corporate application to keep an eye on whether the Large Hadron Collider has destroyed the world yet. It's been running for a couple of years. They keep throwing more and more energy into it, and one day it might create a black hole and we'll all disappear. And somebody has very helpfully created a website which keeps an eye on this. So I've created... Okay, I've just had a question here which I'll take immediately regarding the @. The question was whether this is the cut operator. No, it isn't. This is the merge operator, which has been discussed, I think, by APL interpreter vendors for as long as I can remember. And we've finally come up with a model of it. If you're interested in that, come back in a month when we do the version 16 release webinar. We'll definitely be talking about @ because it's one of the really cool things. Okay, I think... Okay, there's a question about whether a demo in Paris where we showed graphs using .NET, that's quite likely if... yeah, that was probably Sharpplot. Sharpplot on .NET, on the Windows platform, will use an engine compiled into C#. It'll run a little bit faster, or significantly faster, perhaps, but it's available on all platforms. So the exact same APL code will be able to drive Sharpplot on Linux and on the Mac as well. So you can combine it with the HTML renderer for the output. Okay, so returning to the Large Hadron Collider, I've created, as a child of my form, so f1.areWeStillHere, I've created an HTML renderer, and rather than having it as a free floating window, I've specified I want it as a child of the window. So it's created this space here, size 400 by 500. And the next, oops, I've got a little problem with running the demos. The next thing I want to do is to set not the HTML property of it, there's also a URL property which you can just set directly, and that will then direct that renderer to that website. And we can see that the answer is still a good one. What we want. The other thing that we want to keep an eye on all the time is the Dyalog Twitter feed. And so I went to twitter.com, and there's a menu item you can select, and it'll give you this little bit of HTML which you can see in the bottom 2 rows here. And that's something you very often get when you're working on the web, is you can go somewhere and you can get a snippet of JavaScript or HTML that somebody provides to you so that you can easily access their service. So having that, I can now create another HTML renderer, and this time I will actually assign that to the HTML property, and you can see that we now are taking advantage of externally provided HTML-based functionality as part of an old application. So that's another thing that we think people will start to use more or less immediately. Now, if you actually want to start creating your own user interfaces from scratch with this HTML technology, that's where we face the more interesting design. So here's an example of one of the things that we're playing around with. See if I can save myself some typing. Interactive. So we're working on Now this, people may decide they don't like this at all, but one of the things that we've become accustomed to as APL programmers with QuadWC is being able to interactively create widgets and see how the user interface looks as you build it up. So here's an HTML renderer. I have to set a flag to say I want to run it in interactive mode because there's some overhead, and if you're running an application you really have no need to see the controls appear one by one. So I'm going to add a title of Hello World to the document object model of this page. I'm going to add some style where I say in the body of my page I want to use this font, which has the effect that when I then add a text object like a header level 3, it uses that font. I'd like to have some input fields, which requires me to create a form. And then we've created a number of objects, so this underbar input is similar to a QuadWC edit. And we actually have about 200 of these now, which are a combination of HTML objects, jQuery UI objects, plus Syncfusion objects that we distribute with Dyalog APL. This is just one of the very simple ones. So the object takes, it's a type of text, there's some content, and you can have a label which by default is positioned on the left, but there's an option to say you want the label on the right. We'll add a little bit of spacing and then a button. Press me, and I suspect our CEO is watching this somewhere, or she'll come and watch it later, so I'd better style this correctly. Then a very common technique when creating HTML-based applications is that you have a thing called a div or a division that you're going to replace later with some other content. So here's my callback function. Callback function receives some information about the postback request, the same as it would in a QuadWC application. And then what we do here is we have a number of options. We can replace, for example, in the page, the output div. So we're manipulating the contents of the existing web page, and we're replacing it with in bold, thank you, plus the current value of the FN control, which is the first name. So we then wire it up. We say the button 1, if you click on it, call this function. And if we press the function, it works. And of course, this is all very dynamic. So if we edit that function and we decide that that text was really uncomfortably close to the button, we can put in a line break into the HTML. And if I press it now, I get a bit more spacing. Yeah, so we can interactively add controls and see what it looks like. How practical that will be when you create really large applications, I don't know, but I think at least while you're learning to use the technology, being able to do things interactively is quite nice. So I'd just like to show a couple of the Syncfusion controls. So these are like the grid object that we have in Dyalog APL. There's dozens of them. Just like to showcase a couple of them. So here's some data. We ship some data with IQs. I hope those are not intelligence quotients, but it would seem they might be. Here's just a defund that generates some random levels because I want to show off the tree grid. So this data doesn't make a lot of sense, but I have some people with some names, some IQs, and then I've generated a tree view. Right, so there's a question here. Is it possible to load or save a CSS file? And I presume that then, let me just draw this tree view. So here's another HTML renderer. You can have several of these open at the same time. I wanted to set the size of that. And then, of course, it went and hid. I want to add an enterprise Java Bean tree grid. But I wasn't in interactive mode, so I now actually have to tell it I want to render that. Okay. So now I'm not sure if exactly what the question was, whether you wanted this tree grid to be loaded directly from a CSV file. I believe the many of the Syncfusion controls actually do have that kind of capability. They can load data directly from external JSON or CSS files. Otherwise, of course, I could easily have read this data with... well, actually, I did read it with Quad CSV and inserted it into the control. Another funky modern control that you see on a lot of social media apps, you know, things that are trending, what's hot. So here I've decided that what's hot is based on the quad size of how big a class is. So the hotness of these namespaces depends on their size. Create another HTML renderer. Set its size. And in this case, I'm adding a tag cloud object. And the tag cloud object, again, we've covered this in APL in the style of Quad WC to make it easy to use. So it takes an APL matrix with 2 columns, with the strings and the sizes. And then when it renders it, we see that we get these font sizes according to how hot, how trendy the word is at the moment. One of the things that's quite different about this modern UI technology is that typically you don't do layout based on pixel positions, but it's all done typically using objects like the one called a stack panel. So I'm adding a stack panel and I'm saying I want it to be horizontal. Then I'm adding the tree grid to the stack panel, a no break space to give me a little bit of horizontal space, and then the tag cloud. So I now have a stack panel with 3 elements horizontally, and when I render it I then get them next to each other. So typically the way layout is managed in these HTML, JavaScript applications is you use these, as it is with XAML when you're using other modern frameworks for UI that have followed after Win32. It's all based on relative automatic resizing and so on. So those are the low-level pieces. I'm going to wrap up by showing you a couple of tiny micro apps that have been built last night by a couple of very hard-working people. The first one is actually Adam built this some time ago. His 2048 game has been available as part of the My Server samples. But what we've been working on is to make it look a bit more appy. Yeah, ignore that. That's just beta fluff. So here's his 2048 game. I don't know if you're familiar with it. I've been trying to learn it. It's something about you can tilt the board using these 4 arrows. If I tilt it left, then all the numbers fall over to the left. And if I do it again now, I get these 2 2s in the bottom left next to each other. And if I tilt the board so that 2 equal numbers collide, then they're added up. So you add things up, and the idea is to get to 2048 in as few keystrokes as possible. The purpose of this obviously is not to learn to play the game, but to have just a wee look at the code here to give you an idea of what, you know, the complexity of the code, and compare it to how things would be with Quad WC. So if we have the board over here, we can see the main code that creates the board is essentially these 8-9 lines of code here that add a title 2048. This is a Unicode character identifier. I think it's this curly the start a new game icon. Some text, use keyboard's arrow keys, and then in the middle there's the display of the board, And that's a sub-function that's called here, which just creates a table object with the current contents of the board and all zeros replaced by spaces using the @ So I don't really want to go into the detail of this here. We may have a webinar that goes into much more detail on how to use this later, unless if there are some people who would really like a deep dive in this application and the next one that I'm going to show, pose that as a question, and maybe we can carry on for a bit, depending on how many people want to see that after we've finished the presentation. One of the things that I think is worth showing very briefly is that the exact layout, so the spacing, the rounding of edges, the colors and so on, is typically done with this language called CSS, Cascading Style Sheets. And it's actually something that I think most APL programmers can learn to use very quickly. It's a very data-oriented structure. So this line here, for example, says that anything which has, I think, a class of slide is going to have a background of dark orange. And these buttons here are dark orange. So if I were to change that to mindful that the CEO is possibly watching to purple, and I change the border radius to 0, and then the board table data elements, which have this color here, I will turn pink. And then I say, now fix these functions. Don't update the file, because I don't want to write that back to the repository. If I then start a new game, it immediately picks up that style. So the process of working with styling, spacing, and so on is really separated from the application code. All of the application code is this very APL-y stuff down here at the bottom, which is all these functions that rotate and slide and detect whether you've had collisions and whether you've won and so on. So this stuff down here is all very classical, very functional APL code. And then the amount of user interface code I'm claiming is very, very similar to what you would see. And one of the advantages if you're a domain expert working in a large organization is you can sit down with professional designers and you can agree with them what class names you're going to use for your controls and so on, what names, what IDs, etc. And then professional designers can use design tools to create all of this for you. They may have a corporate standard that you just need to follow, and then you can very easily style your application in the colors that the corporation would like you to use. The other application that Brian has been working on is a little weather app. Hopefully we have an internet connection. So this is something which goes out to the NOAA and for any American zip code. Let's use one that I'm told everybody knows what this is, 90210. Beverly Hills. So there's a bit of response time. This isn't the world's fastest web service. In fact, it doesn't seem to be responding at all. Ah, there we go. So everybody's woken up in the US and is getting weather data, and the service is very slow. I mean, this is a public free service, so there's really nobody you can complain to. There's two services here. There's the NOAA, and then there's Google themselves, who provide an API for embedding their maps. You have to sign up, and they give you a snippet of JavaScript to embed in your application. So again, there's not a huge amount of code. I'm not going to go into the detail, but it's creating, it's actually very similar to the kind of code you would have in QuadWC. You're creating inputs. There's making a chart, making a grid, and so on. The amount of code in, say, making the grid, this function here in the middle, we got some data from the weather service. We're doing a bit of very typical APL massaging, removing missing values and so on. And then the UI is either inserted into a tree grid, or there's a chart, and here we're using the SyncFusion chart rather than Sharpplot. It has some features like animations and so on. So if we go back to the application, but again, the amount of code here is very similar to what you would have had if you were creating a Sharpplot grid, is my claim. And you get effects like being able to hover over data points and getting pop-ups. And we can switch to the tree grid, switch between the tree grid and the chart, so on. Okay, so those are some use cases that I threw together, and I'll now return to PowerPoint. So for those who actually want to understand a bit more about how this works, if you have Dyalog APL and you execute this QuadWC HTML renderer and give it some HTML, what happens is it loads something called the Chromium Embedded Framework, which is the same engine that's at the center of Google Chrome, and passes the HTML to that. It renders it. And if you've set up a callback for on HTTP request on this object, then when the user does anything that would cause the browser to post back, either using AJAX or a regular GET or POST, that is sent back and it's intercepted and passed to APL infrastructure that we're creating, which will eventually call your function, as we had with that button there. And the exact same application code can be used with my server, where instead of the HTML renderer object, you're using TCP and our web server framework and a real web browser at the end. The way it works is exactly the same. You can decide whether you want to run on a desktop, phone, etc. Okay, so what we're really keen on engaging the user community, because although the HTML renderer itself, the QuadWC object, is unlikely to change much, we think we understand how that needs to work. There will be features that need to be added, like being able to run without a title bar, no Chrome, maybe being able to create a menu. So if you're on a Mac, for example, you want the menu integrated with the system menus. Features like that might need to be added to it for better integration with different operating systems. It's the HTML generation part of it that's more experimental. So we have everything I showed you now is code that's evolved over the last several years as part of my server, but there may be things that need to be different on the desktop. There may be other models for generating the HTML. So we have some ideas that we will continue with, but we would really like to work with those of our users who have needs to build these applications to work together and hopefully create a tool layer that everybody will use, rather than having people design their own. One of the things that people can really quickly help with, and we've actually seen people already commit changes to our GitHub repository, is in the code. I didn't actually look at this, the function I'll show you. We looked at this make grid function. So when there was a redraw event, we called make grid to replace the grid. And we also replaced the map div with the result of something called get map. And while the make grid function was a nice, a little bit of data massaging and then a single call to this EJ grid object with the data matrix and the tree levels, one of the functions we didn't look at was this thing called get map. And that's the kind of thing that your average APL programmer doesn't want to have to write, because as you can see, there is generation of JavaScript in it. So, Brian went out, read the Google documentation, figured out how to write this code. And what the next thing to do is say, well, is embedding a map something that people are likely to want to do in a lot of applications? Probably yes. So it's quite easy to take these two functions here and put them into an object like this EJ tree grid, so that the user would end up writing something that, where the redraw function would end up looking like this, where you just have something which says replace new Gmap with the latitude, longitude, and the zoom factor. Okay, I see there's a question. Is on HTML request the only event? And the answer to that is yes. So the way the onClick works is that when you created a button, the button object, it embedded some JavaScript along that you don't see, but that was generated by our UI framework, that's able to deal with any of the very wide range of events that that you can have in JavaScript. It captures those events and then does an Ajax style postback using on HTTP request, on HTML request. I think it's the correct name now is HTTP request. That's one of the things that changed recently. And then the framework receives that HTTP request, sees that it's a click, and then has this table of functions to call to dispatch to. So the underlying technology is the interception of HTTP requests, which is soon, but not in the current release, going to include web sockets so that you can have bidirectional data binding events and so on. But it's not a this is not an interface to the document object model of the browser, because we also want to be able to support the model where your APL application is running on the cloud and it's actually talking to a real browser. It doesn't have the object in memory. And that's why the choice of using the HTTP interception, which is also something which is very straightforward to do with the Google framework, they support that, is the way we've decided to go. It allows us to write tools that will work on all platforms. If we tried to really bind directly to the object model and JavaScript, we would end up with something which was somehow very platform or very technology dependent, as far as we can see at the moment. But the user doesn't see that, right? The user just wrote on click my function. Okay, so the next question is whether READ uses the HTML renderer, and that's a very, very good question, because that is in fact my vision for the future, is that you'll be able to run a cloud application, so yeah, a micro application of some sort, and it'll be able to use the HTML renderer, but that will tunnel all the HTML through the READ protocol to something that's running on your desktop. So without having to run a real web server, so single user computing, you start your own little image up on a cloud somewhere. You don't have to integrate with the company's Apache or whatever server. Okay, so there's another question now I see from Paul. It says, what does this do that you can't do with a web browser other than cross-platform? Other than comparing it to the Microsoft, so embedding using COM, I think the question is here. So embedding using COM, the Microsoft web browser object. And I think the answer to that is it doesn't do anything other than cross-platform. But if we're going to have a new technology that really will be usable for another decade, then we think that keeping it platform independent is absolutely critical. Otherwise, we'll be caught in an endless cycle of 3 to 5 year technology revisions. How long is the Microsoft web browser COM object even going to exist? I wouldn't want to bet on that. There'll be something like it, and with minor rewrites of your code, you'll be able to port it. But we think this is an appropriate level of technology. Okay, so I see Stefano's made a comment which isn't really a question. He's pointing out that the Chromium embedded framework is much younger than the Microsoft web browser, though I wonder whether there aren't, I mean, Microsoft must have some new .NET Core web browser objects that use the Edge engine or something. One of the I'm going to say one of the attractive features is cross-platform, and that really is important, right? Here, if you use the HTML renderer, you would be in control of which HTML rendering object is being used, right? You would ship with Dyalog APL the Chromium embedded framework of your choice. You could choose to pick up one which was already on site, but I think if you use other components, it becomes much harder to control your destiny. Yeah, I hope that... were there other questions?
There's arguing going on about that.
There's arguing going on. Yes. Yeah, I mean, these are good questions. And I've actually been thinking we might want to, I don't know if you, some of the people listening in today may have been to the meeting that Dyadic Systems once arranged, organized at the beginning of the .NET adventure with, to bring together some of the most experienced UI developers to talk about this kind of technology. It may be time for another event like that. Maybe we can manage it online, though this webinar technology with the limited interactivity probably isn't, it's not a good room for an argument. Yeah. Okay, so I should wrap up. I think we've, our intention was to run for about 90 minutes. We must be at least there. Oh, pretty close. Excellent. So I'd like to thank Brian and Adam in particular for very hard work over the last 48 hours and very little sleep. John Daintree, of course, for all the work in the old UI Foundation, and it's amazing to have him to help us embark on the next one. The NOAA and Google for the stuff we embedded in that application. And of course, everybody at Dyalog. The Dyalog interpreter is the work of very, very many people. So I hope those of you who are still out there enjoyed that, and those who also come and watch this later. As I've said a couple of times, the plan is to do this kind of thing roughly monthly. On a Thursday, we think is a good day. Please do provide feedback on all aspects of how we did this, how we picked the topics, how the technology worked for you. The next event that's scheduled is at the end of June as we roll out version 16, knock on wood. We think that in the future, probably webinars will be shorter than these two initial ones. They'll probably just be a single topic rather than multiple topics, and the time might be down to 30 minutes. We think we'll also record a number of videos on how to use APL for various things and just post those without an interactive capability. And there'll be something live from Dyalog 17, I think, but I don't know exactly which session we may or may not decide to broadcast. Okay, yeah, so if let's say there are some nice comments. Thank you very much. And, if you give us good feedback, we'll be very encouraged to do it again. So thank you all for listening in, and see you next time.